Happy holidays, Merry Christmas. He went to the restroom. Our intro and our outro is in the little outros room. The last time we were together, we were talking about angles inside of a polygon, and we figured out how to calculate the measures of all of those angles by drawing diagonals and creating a bunch of triangles. Well, we're going to step another step away, and we're going to be going with a very particular kind of polygon. We're going to be looking at the four-sided polygon, the quadrilateral, but in particular, the kind of quadrilateral in which both pairs of opposite sides are parallel. That will be the definition for this quadrilateral, and we call this kind of quadrilateral the parallelogram. Dun, dun, dun. When we name and write the name of a parallelogram, we're going to use this symbol. Okay, I know it looks like a rectangle and it's horrible looking, but it's supposed to be kind of a little slanty. Okay, so make your best slightly slanty rectangle, and you'll have drawn the perfect parallelogram symbol. We have four properties of parallelograms, and I'd like to go through them one at a time. I'm going to zoom in here on the left-hand side, and then we will scroll over to the right as we need. I need my cheat sheet. I don't remember them all. Okay. The first property says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, that is, both pairs of opposite sides are parallel to each other, then those opposite sides are congruent. Okay, I'm going to scroll here to the right so that you can see the diagram. There's our diagram. Here's a parallelogram. We're told it's a parallelogram. Notice that this side is congruent to this side because they're opposite of each other, and that means that these two sides are also opposite. Okay, there's our parallelogram. The next property says that if we have a quadrilateral and it is indeed a parallelogram, then its opposite angles are congruent. I'm going to scroll over to the right here in a moment so we can look at that diagram and we can find where those opposite angles are and do our congruent markings to show that they have the same measure. Here's our diagram. We're talking about this corner being congruent to this corner and these two corners being congruent to each other as well. Okay. The third property of parallelograms says that if our quadrilateral is a parallelogram, then its consecutive angles, that is, the ones one right after each other, these consecutive angles are going to be supplementary. What did supplementary mean?
180 degrees.
Yep, they add up to 180 degrees, and so I'm going to write that here as a little reminder to ourselves that supplementary means sum equals 180. Remember that sum means we're going to add up a bunch of stuff. Okay, so let's scroll to the right to look at that diagram. There's the diagram to the right. What this means is that these two angles are supplementary. It also means that these two angles are supplementary. And these two, do you see a pattern? Okay. If a parallelogram has one right angle, then it has four of them. If it has one right angle, it has four. Let's look at y. All right, here's a parallelogram. This is a right angle. The second property of parallelogram says opposite angles are congruent. So if this is a right angle, then this is a beautiful. Third property says that consecutive angles are, which means they add to 180. So if this is 90 degrees, then this has to be. And opposite angles are congruent. So if this is 90, then this is. If there's one right angle, all of them are right angles. Yeah? Very. All right, we have 9 different examples for us to work through. Please pick your least favorite for us to work through.
5.
Number 5 and 6. All right, let me circle those so that I remember 5 and 6 is what has been requested. All right, let's look at number 5 first. It is definitely the weirdest looking. All right, this is a parallelogram because if I scroll up to the directions say find the value of each variable in the following parallelograms. All right, properties of parallelograms. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. I don't have any right angles, so I'm going to ignore the fourth one right now. Okay, wait a minute. Opposite angles are congruent. That means that 5x is equal to 2y. Okay, I can write that equation, but can't really solve it yet. I didn't do anything wrong. I just didn't get anywhere. So I'm going to look again.
Well, couldn't you do 5x plus 60 plus...
Yeah, I could do the angles at this corner plus the angles at one of the other corners, and that equals 180. Because our third property says consecutive angles are supplementary. All right, did you want to do to the 5x?
Yes.
Okay, so then we'll do this angle that I colored in pink plus this other angle that I colored in blue. And those two together are supplementary, so when I add them, I should get 180. And now I have an equation that I can solve and get a value for a variable. All right, gonna do some combining of like terms. I know it ends in a 5. 115. Okay, I'm just gonna write it down and believe you because I was having trouble thinking through the rest. Okay, gonna go ahead and subtract that 115 from both sides because you were in the way, sir. Goodbye. 5x equals
65.
Thank you very much for rescuing me from that particular bit of math. And then I'm going to divide both sides by 5.
I can get 13.
Okie dokie, I'm gonna believe you because you said it with such precision. Oh hey, now I have a value for x, right? Dude, now this one becomes really easy. And y equals 30 something.
32.5.
Okay. I'm done. All right. Let's look at number 6. Pausing here because I had a couple people go, oh, wait. So I'm pausing myself in real life. Ready? Okay. Scrolling over to the right, we're going to look at question number 6. Here's question number 6. We were told this thing's a parallelogram. What do our properties of parallelogram say? Opposite sides are congruent. And that's really the only thing we need here, right?
Mm-hmm.
All right, I'm going to start writing equations. I'm going to start with the pinks first, just because when I look at those two different values, I notice it's only going to give me one variable. Whereas if I write the blue stuff, like I can totally write that equation, but I have 2 variables and I can't solve it yet. So I'm going to solve the one that I wrote in pink first. Divide both sides by 30 and x equals, okay, thank you. And now I have a value over here for 5, so I'm going to take this equation And I'm going to substitute in the 5. Oh God, 72 times 5.
360.
Okay, thank you. I was like, it ends in a 0. And that's about as far as I got. Dividing both sides by 2, I can do that one.
Y equals 180.
Voila. Feels okay? Do you want to see any other examples in this section? All right, I'll leave this for just a few more moments as I see people copying down. When you're ready, please meet me on page 2 of our notes.
Can we get the worksheets for this one too?
Yes, it'll come out tomorrow. I don't have it ready.
Thank you, thank you.
Thank you.
Bless you, bless you.
When are we gonna get our semester exam review?
Can I talk about that after lecture? Thank you.
When does it
Miss, when does the bell ring?
31. So any second now.
I felt it. I'm like,
It's going to ring any second. All right, we're going to talk about diagonals of our parallelogram. We've already talked about the sides and the angles being congruent. Now we're going to talk about the diagonals. Remember, those diagonals are the lines that go from corner to corner through the middle of our shape, not along one of the edges. Okay? So our first property of the diagonal says that if we have a quadrilateral and it's a parallelogram, then its diagonals are going to do something really special. The diagonals are going to bisect each other. What does bisect mean?
cut into
Beautiful. All right, so I'm going to scroll over to the right in just a moment so we can look at that diagram, and we will go from there. Here I go.
How
Scroll.
long is diagonal one?
Diagonal, like you see these lines right here? They go from corner to corner, cutting through the shape. That's the diagonal. Okay, so we're going to be looking at those. All right, here's our figure, and I'm going to zoom in real close on this figure this time because it's kind of printed a little small on my paper. So here's some sort of parallelogram. We're told that in the hypothesis of this statement. Notice that we've got marked opposite sides being congruent to each other. We've got some diagonals happening. This diagonal is being intersected by this diagonal, which means this diagonal is cutting this one into 2 equal pieces, and this purple diagonal is cutting this pink diagonal into 2 equal pieces. The squiggle is because I get lost when I write more than 3 lines in there.
So it's segment bisector, it's not angle bisector, right?
Correct. It's not an angle bisector. I think we could probably prove that it ends up becoming an angle bisector, but the property doesn't state angle bisector. It says segment bisector. It bisects the diagonal. Okay? Yes, ma'am. Oh, okay. All right. On to the very last properties of diagonals. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram. I don't have enough room, so I'm going to use symbols. Please use words if you don't remember the symbols. Each diagonal separates the parallelogram into 2 congruent triangles. If a quadrilateral is a parallelogram, then each diagonal is going to separate that parallelogram into 2 congruent triangles. Let's scroll to the right. Let's look at the figure and use it to just kind of talk ourselves through a little mini paragraph proof. We won't write anything, but we'll just talk ourselves through it, okay? So I'm going to scroll and I'm going to zoom so we can look at it closely. All right, here we go. ABC is a parallelogram, all right? Based off of what we know of parallelograms, what's true?
Triangle ABD is congruent to CDB because if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram.
Yep, and that's what the property says. But let's figure out why that property is true, so that way we know that we can rely on it whenever we want, okay? based off of just a parallelogram, what do we know about these opposite sides?
They're congruent.
They're congruent. Okay, and the same with the others? All right. Here we go. Now we're looking at these two triangles and we see they're separated by this one side. Reflexive property lets us say that that side is congruent
To that side.
to itself. What postulate for congruent triangles do we have that uses three pairs of congruent sides?
Side, side, side.
The side, side, side. If we have two triangles and all three pairs of sides are congruent to each other, then the triangles are congruent. We also have a property of parallelograms that says that opposite angles are congruent, don't we? So we could have, instead of using the reflexive property, used, oh, opposite angles are congruent. And then we had side, angle, side set up. And so this property is doubly proved. We could prove it by all three sides congruent, or we could prove it by side, angle, side. Okay? So now we know that it's safe to do exactly what you did at the very beginning of, I got a diagonal, these two triangles are congruent, I'm washing my hands and I'm done. Okay? We have 6 examples that help us deal with the kinds of things that we've been working with. You guys get to choose. I'm going to tell you right now, 2 of them we can do with all the information we have right now, but 4 of them
Well,
are going to be more easily accomplished with something we haven't talked about yet, but likely was seen in your Algebra 1 class last year. So it'll be, if you saw it, it'll be a recall. And if you haven't seen it, it becomes a spoiler alert for when we come back from winter break. Okay? She called for number 12, you said. Number 12 is one of our spoiler alert items. Do you want to start there, or do you want me to pick one of the ones that I know isn't a spoiler alert?
Let's just do it.
Start.
Let's just do
there.
it. Spoiler alerts. Spoiler alerts. All right, let's look at what we have. We have a parallelogram because if I scroll up to my directions, it says parallelograms. And we want to find the value of each variable, so I'm going to have to find the value for x and for y. Okay. Well, I know that diagonals are going to bisect each other, so I know this piece is going to be equal to this piece. And I know that this piece is going to be equal to this piece. I know that this side is congruent to this side. If you're writing one color, make your congruent markings. If you're writing in different colors, follow the color pattern for your congruences. Okay. I've got to figure out how to relate these triangles, because I don't know yet whether they're congruent or not.
Whoa.
isn't 17, the side 17 and the other one?
Yeah, this side 17 is going to be congruent to this side 17. Okay.
Do you need to put 17 instead of 14?
Oh, yes, I'm
Wait.
sorry. This was supposed to be
Also this-
17.
Since that part of the triangle is a right angle, doesn't that mean that the opposite?
Yes. Yes, it does. Okay, so that means this part here is x.
And then also the things on the same line will equal 90.
Well, these things here can be 90, but that doesn't mean that this stuff in here is 90.
Oh, I'm stuck with the one right of me.
Here?
Oh. Yeah,
Yeah, it's just these sides.
okay.
Because it's tilted at such an odd angle that that's really all we can say about it. It becomes an alternate interior angle-y kind of thing.
They're not vertical angles?
These two are, yeah.
So make
Those
them-
two are vertical angles.
make them congruent.
Yeah, it makes them congruent. Which lets us say that these triangles are congruent. So I could totally do this. This part is y. And this part is 4. I haven't done this one yet, guys, so I'm having to work through it right along with you. Yeah. Oh my goodness. Okay. I have this triangle right here. I found it. This big one right here. You see it? Okay. I know this big side right here is going to be 8. I don't know what this is, and I know this is 17. And it's a right triangle, and there's our spoiler alert. We found the right triangle. All right triangles have this property.
B squared.
Oh, a squared plus b squared equals c.
Yes.
That
Oh,
theorem?
right, Pythagorean.
The Pythagorean Theorem.
Oh, you talked about that.
Yeah, we did. I extra spoiler alerted this. When was it? When we had snow day on Friday? And I showed the crazy video and she was like talking super like that? Yeah, Pythagoras and his cool kids club.
And he hated beans.
And he hated beans. Like frijoles, beans. He didn't like beans. Okay. So we need to figure out which is A, which is B, and which is C. Here's how I remember it. A and B make the right angle, and C is the one across from it. Okay? So A is colored in blue, so that's going to be 4 plus 4 or 8. They're always going to be, one is the base and one is the height. They're going to form the 90-degree angle. Doesn't matter which order. As long as you get both of them that form the 90-degree. And then C is the other one. B is played by X. And C is being played by 17. Oh, right. And now I can solve this equation for X. And once I get X, I should be able to do something for Y. Okay. So 8 squared is, all right. I'm leaving X squared all by its lonesome. 17 squared is, thank you. Someone has a calculator app or has it memorized? Calculator app? Right on, buddy. I am down with that. All right, subtracting 64 from both sides leaves us with 225. Okay, you saw me starting to. But I don't want X squared, I want X.
Gotta square root that.
Yep, square root that and X equals? I believe you.
Luckily,
I have that one memorized. Confirm it?
it's correct.
He's like, hang on, let me do the thing.
I know it.
You did this one, bless you.
Alright.
All right, huh? Oh.
Oh.
Oh, our brains have failed us. That's okay. 15, that's okay. All right, we have X. So we have a 15 right here. But wait, there's more. Look right here. We have yet another right triangle where we have 2 sides and are looking for the third.
Oh, no.
I'm running out of colors.
Why would you say those triangles are congruent because it's an equilateral? I mean, quadrilateral.
Yes, but that we need to get this Y in here. So that's why I'm grabbing that little yellow one that I colored in. Do you see it? The little yellow one? All right. So we're going to do the Pythagorean Theorem again, but we're going to do it to the little yellow one. Okay, I'm going to scoot it over and I'm going to do it right here in this space so that we can still see everything. Okay, I'm going to write it again. A squared plus B squared equals C squared.
Equals C squared. And then it's,
Okay, I'm going to try to speed up a little bit. A is 4 and B is 15 and C is Y. I don't know what Y is. Okay, so 4 squared is 16. 15 squared I already had. It was right here at 225. Yep. And then Y squared I'm leaving alone. 16 plus 225 is...
31.
Thank you. And the square root of 231. Oh, it's 241? Okay, square root of 241.
It's 15 with a bunch of decimal numbers.
15 with a bunch of decimal numbers, so we're going to leave it as a square root of 241.
Oh, God, I don't wanna solve
Because
that.
I'm feeling too lazy to try to simplify this right now.
Alright.
We won't do this one. Because I can't easily think of factors of 241.
What's that guy's name? Pythagorean?
Pythagoras?
He would have been mad.
He would have been very mad because that's not a whole number. All right, feeling okay? Spoiler alert on Pythagorean Theorem, we're going to play with it. Here's the good news, is if we look at number 10, it's going to be the same way, but look at that 30-degree angle sitting in there. Can I scroll over to show you number 10?
I write like a 6-year-old.
It's okay, me too.
You have no idea.
I swear my daughter, she's 9, has better handwriting than I do. Okay, can I scroll over? Yes? Okay, so scrolling over to number 10. Look at that 30-degree angle. Okay, this is 90, this is 30, so what's the measure of this? The Pythagorean theorem will totally work here.
Hey, how do you know it's 90? Because it equals 2.
Because of the triangle angle sum theorem.
Oh, Jocelyn.
This right here, this little box gives me 90 degrees.
Oh, I'm sorry. I thought
It's okay. So, spoiler alert, after we look at the Pythagorean theorem again and we practice it, we're going to be able to use a shortcut on these kinds of triangles that are 30, 60, and 90. And then you don't have to use the Pythagorean theorem. You literally can just plug numbers into a pattern and it spits out all of the side measures. But only for 30, 60, 90, and one other special one which doesn't appear on this paper, so we'll deal with it later. Okay? I'll give you those when we get there. It'll happen sometime after winter break. All right? Does anyone want to see another one of these, or are we feeling okay? We're okay?
Yes.
All right, then let's work on the proof together. This is the last one, and then we are done. It wants us to write a paragraph proof. Remember our goal with these paragraph proofs right now aren't to feel amazing after each one, to be like, oh, I get it a little better than the last one, okay? All right, given, what are we given?
It's a parallelogram.
And it's named ABCD. That's all we're given. So
There's 4 sides.
there's 4
Because
sides
there's 4.
because there's 4 points, and I might as well draw a picture so that I have something to look at.
And therefore, one of the properties of the quadrilateral states that AED will be congruent to
Wait, I don't
CEB
get it.
because
Okay, let's take a look. Let's draw it, and I think I know where you're going with it. Okay, so here's a parallelogram, but where do I put the letters?
Who cares?
you put them anywhere.
The great answer was, it doesn't, who cares? No one cares. We care a little bit. We just have to go in order around the parallelogram, but it doesn't matter where we start. As long as we don't jump, we don't care. So, A, clockwise or counterclockwise, it doesn't matter. This way. B, C, D. Okay, so as long as you're going around the edge, we don't care where you start, and we don't care what direction you're going. Just please don't start hopscotching all over the place, okay? Okay, so there's our parallelogram. All right, I'm going to keep like a quick outline of the statements we're making to make the paragraph proof writing easier at the end. So the first thing we did was we talked about the given, and we drew it. All right, let's look at the proof. Where's E?
I think
little-
it's a diagonal.
it's a
Yeah.
line.
Yeah, if we drew diagonals, if we drew 2 diagonals, they'd intersect somewhere, and I could name that point E. Okay, so then let me draw my diagonals, and I'm going to draw them a different color so we can see them. And then here's my point, and I'm going to name it E. And so the second thing we did was we stated that diagonals intersect at E. All right. We want to prove that this triangle, AED, is congruent to this triangle, CEB.
Well, they're both on opposite sides. That's fine.
Okay, so they're both on opposite sides. What does that mean?
congruent, which is the property of parallelogram.
Opposite sides are congruent, so I can say these are congruent because of property. Okay, so.
Opposite angles are also congruent.
Okay. Wait. Slow down for me. Okay, these segments are congruent because property of parallelograms. Okay, so we've got 3 sentences so far.
And then we also know that AC is a diagonal, so it bisects AE is congruent to EC.
Okay, so here's a diagonal, and the diagonals, when they run into each bisect each other, that means this thing is congruent to this thing. CE congruent to AE, and this thing congruent to this thing.
Which gives you enough to say you have.
Okay, hang on. I'm slow, remember? Okay, these two because property of diagonals.
Just side angle side theorem. 'Cause they're
We don't
vertical.
have any angles.
Yeah, the vertical.
Okay, we could come in and say these angles are congruent for vertical angles.
And we could also say that they're opposite angles.
Opposite angles would be these corners.
Oh, all that, you're right.
So we'd have to go vertical.
Yeah.
Okay, so we could go vertical. Vertical angles are congruent for side, angle, side. Or we could get there right now, before the angles.
Side.
Side.
Oh, yeah.
Which one do you want? Doesn't matter, they're both valid.
Side.
Side, we already have it. So triangles are congruent because side. This paragraph proof should only have 5 or so sentences. We could combine sentences to make it sound fancier and have fewer sentences, or we could break these up into more than one sentence, again, to sound fancier and have more. But as long as we hit these 5 points, our paragraph proof is done and good.
It's a lot to hit, actually.
It can be. I've seen longer though. So I think we're,
No, it's in
let's write it. Okay. I'm just going to write based off of these 5 things, and I'm going to zoom out a little bit so that way, there we go. Okay, so I'm going to start with the given. We were given a parallelogram. Okay, so given parallelogram ABCD.
Wait, can we not write? What?
Nothing.
Can we not write symbols?
Yeah, we can't write symbols in a paragraph proof. I mean, we're going to be able to do it when we get to these, but we shouldn't on this so much. Okay, given parallelogram ABCD, let the diagonals intersect at E. And I don't need to write the word point. If you just write a capital letter, we're going to assume you mean the point E. All right, so we have taken care of the given, and we've taken care of statement number 2, all in one sentence. Then we were told this segment congruent to this segment because of property. So I'm just going to turn that into an actual sentence. I could use symbols here, like this. Line segment CB is congruent to line segment AD because, or due to, that works too, because of the properties of parallelograms. And this whole mess of things being congruent because of properties of, yep, the diagonals. We did this one and this one. Therefore, by side, 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 triangle AED is congruent, triangle CEB. And we're done.
That's all we have for today.
That's all we have for today. Thank you very much. He's a little sleepy today. Thank you guys very much.